This is Andromeda, our closest galactic neighbor. So many stars, it's like sand in the sea. But just think, every single one of these dots is a giant star, individually visible to us 2.5 million light years away. Each star likely has its own planets, comets, asteroids, its own story. The Hubble Space Telescope has just created the most in-depth and complete image we have ever seen of the Andromeda Galaxy, and we're seeing it in a new light. A light so brilliant and bright that by the time we get to the galactic nucleus, the stars are so densely packed together that they appear like a brilliant, solid, golden glow. This is no gentle spiral in the night sky. Andromeda is home to violence, a place whose presence has cataclysmic consequences for those nearby, including us. I'm Mahuadine, and you're watching Galactic Mysteries. Join me today as we take a trip next door to the Andromeda Galaxy and explore arguably the most impressive image of another galaxy ever taken, including 200 million of its stars. We'll show how Hubble's groundbreaking new portrait is being used to piece together Andromeda's turbulent past and predict what violence might be on the cards in its future. We've been observing Andromeda for more than 1,000 years. It was first spotted in 964 AD by Persian astronomer Abd al-Rahman, who described what he saw as a nebulous smear. And we didn't really get a better look than that until nearly 700 years later, when on the 15th of December, 1612, Simon Marius became the first ever person to observe the Andromeda Galaxy through a telescope. Slowly but surely, more details of this seemingly fuzzy nebula emerged. Charles Messier officially classified it M31 in 1764. But one of the most important breakthroughs came 100 years later. The third Earl of Rosie, William Parsons, was a keen yet eccentric amateur astronomer. He had the massive 72-inch Leviathan of Parsonstown telescope built in the garden of his Burgh Castle in Ireland. It remained the largest telescope in the world for some 70 years. Parsons used this beast of a scope to spot the spiral structure of a nebula named M51, or as it's known to most of us, the Whirlpool Galaxy. It was the first time a spiral structure had ever been seen in a nebula, and the discovery sparked a flurry of interest from astronomers of the time. As they turned their attention to other nebulae, it resulted in the first ever photograph of the Andromeda Galaxy, taken by amateur British astronomer Isaac Roberts in 1888. And that photo, as you can see, shows a clear spiral structure. Even with this photographic evidence, scientists weren't sure what Andromeda was, but they classified it alongside thousands of other spiral nebulae that all had something else in common. They didn't move like the rest of the stars in the night sky do. This realization inspired one of the major debates among astronomers in the late 19th century. Were spiral nebulae part of our own Milky Way galaxy, or could there possibly be other island universes beyond? In 1925, Edwin Hubble resolved the issue. Hubble identified two Cepheid variables in the Andromeda Nebula. Known as standard candles, these variable stars can be used to measure galactic distances, thanks to the correlation between their period and luminosity. Hubble calculated that these Cepheids were about 1 million light years away, far too far for them to lie within the bounds of the Milky Way, which at the time was estimated to be no wider than 300,000 light years across. With that single realization, Hubble proved Andromeda was a galaxy in its own right, and the universe suddenly became a lot bigger than anyone had previously thought. It must have been annoying to astronomers who thought Andromeda was just a nebula, but a rug pull like this could have been much more painful. Andromeda, or M31, however, doesn't have many of these issues. At around 2.5 million light years away, it's a place where we can study galaxy formation and evolution relatively unimpeded. But to make the best use of this laboratory, we need clear images. Experts and amateurs, ground-based and space telescopes have all taken a look at Andromeda from a number of different angles, resolutions, and wavelengths. But on the 16th of January, 2025, the Hubble Space Telescope released an image that put all our previous efforts to shame. After 10 painstaking years of observing Andromeda, it has created the largest photo mosaic ever assembled. Taken over 1,000 Hubble orbits, it encompasses more than 600 snapshots and 2.5 billion pixels. The result is the most in-depth and complete view we have ever seen of Andromeda. So without further ado, let's take a look. This image shows Andromeda nearly edge-on, tilted 77 degrees relative to our view from Earth. In it, you can see the northern region to the right and the southern region to the left. Astronomers predict that Andromeda could be home to as many as 1 trillion stars, but most are too dim to be detected even with a powerful telescope like Hubble. Nevertheless, it was able to resolve a whopping 200 million stars, making it the most detailed image ever taken of any galaxy anywhere in the universe. With such a stunning census of our closest neighbor, scientists have been able to reveal more about its history, how it compares to our own cosmic home, and how it may evolve in the future. We know Andromeda is a spiral galaxy measuring around 150,000 light-years across, with arms that extend out from its nucleus across the sky. Despite this classification, many of its features are pretty unusual, and thanks to this new image, we're starting to understand why. Created in 2015 with the conclusion of the PAT program, or Panchromatic Hubble Andromeda Treasury, this image is highly zoomable, and it should be. Hubble spent more than 3 years photographing a third of Andromeda's star-forming disk. The images were taken across 6 spectral bands, ranging from near ultraviolet to near infrared. If you take a look at the outer region, you can see an elliptical ring of star formation, found roughly 10 kiloparsecs from Andromeda's nucleus. These newborn stars are bluer and therefore hotter than most other stars in this region. They're also metal-rich, meaning they contain elements heavier than helium or hydrogen. The more you zoom in, the more of these individual stars appear. There are so many, the Hubble team say they look like grains of sand on a beach. The resolution is truly that good. This Rindle star formation puzzled astronomers, and it wasn't the only thing. Using images taken by the infrared array camera on the Spitzer Space Telescope in 2006, researchers found a second inner dust ring situated about half a kiloparsec from Andromeda's center. This one was hiding in plain sight. Initially, scientists had assumed it was a mini spiral related to dense regions of overlapping stellar orbits. 2 rings meant that what scientists were seeing couldn't just be an anomaly. But where did they come from? These rings were about to unlock Andromeda's past. For decades, scientists had looked at the galaxy and found little evidence to suggest a violent history. But these rings showed a different story. As astronomer and author of the 2006 study, David Block put it, these dust rings are like ripples in a pond. And where do ripples come from? A point of impact. That's right, scientists concluded the rings were the remnants of a collision between Andromeda and one of its companion galaxies around 210 million years ago. Just like a stone being dropped into a pond, the impact between Andromeda and this other galaxy produced shock waves of dust that radiated through the disk, leaving behind 2 ghostly trails we can still observe today. Block and his colleagues blamed dwarf galaxy M32 for this impact. Today, it appears as a bright, fuzzy haze of stars found just 5 kiloparsecs from Andromeda's center. When they ran numerical simulations to recreate the impact, the authors found that a head-on collision was able to reproduce the rings we see today. There's a conspicuous hole in the outer ring that was formed when it interlaced with Andromeda's spiral, and the simulations were even able to recreate that feature. Since that discovery in 2006, many thought that we had revealed the extent of our galactic neighbor's trauma, but thanks to Hubble, Andromeda was about to give up more of its secrets. You see, the 2025 image of Andromeda was made from the combined efforts of not only the PAT survey, but also the PHAST survey. This extended the original program to photograph Andromeda's southern region and ran from 2021 to 2024. PHAST added another 90 million stars to the census and expanded its scope to cover 2/3 of the galaxy's star-forming disk. The need for this southern focus survey was born out of the realization that Andromeda's polar regions are almost nothing alike. The southern region appears to be far more disturbed than the north, and therefore carries more evidence of Andromeda's violent history. And there's plenty of battle scars to find. You can't really make it out in the Hubble image because it's too dim, but the giant southern stream is a mammoth feature of Andromeda that spans around 150 kiloparsecs from the galaxy's southern disk into the halo. You can think of it as a stream of debris from a galaxy that was stripped of its stars by Andromeda's gravity. The GSS is dissipationless, meaning